Now, one of the big problems with small diameter lines is the stem conduction or immersion error. And what is happening with this is that the temperature measurement is being affected by the ambient conditions. You know, for example, if we have a process here that's maybe running at, you know, say 121 degrees C, and our ambient conditions are 85, or, you know, room temperature, 20 degrees C. So we've got that delta of 100 degree C difference. And the external portions of the sensor assembly kind of act as a bit of a radiator for the that particular point. And so we're going to have heat conducting along the not only the metal thermal well in the probe, but the actual lead wires in the probe. And that's going to affect the measurement if there is not sufficient immersion length into the process to overcome those errors. You know, one of the ways to help minimize this is to install these sensors in a T. You know, if we have like a 1-inch line, one possibility would be just to stick the probe into an outlet in a T, and so we have the fluid coming by it. And this is kind of my, you know, it's an acceptable way to do it. It just is not the best way. Something that'd be a little better would be to install it into the run of the T. So we've got the flow coming up here. The one drawback with this type of installation is that you have a little bit of a dead lag back here in a standard pipe T, and this fluid doesn't always get cleaned out very well. And if you're running a CIP system, this is not going to get flushed out very well. The better location would be to have the fluid coming directly at the tip of the sensor. That way we get a lot of good washout back here in this kind of stagnant portion of the T. And we can run this sensor down the run of the pipe with sufficient immersion so that we would get a good accurate measurement, and we minimize the effects of stem conduction.